With locking and blocking, how might that impact somebody's performance issues or create them?
Yep. Well, this is one of those things that uh, can, I don't know, it's probably one of the worst performance type things that we run into is when you've got excessive blocking or locking. And it's not as bad as a deadlock, but it's the point that you might have someone doing an update or doing work on a table where it's locked for a minute or 2 minutes or 5 minutes even or longer than that. And while that's happening, nobody else can query or use that table. Uh, what we commonly see on a wait type, what we commonly see in a wait type with that is the LCK underscore M underscore IX wait type, which it means that there is an exclusive lock that is being waited on. And an example is you do an update on a table and maybe do an update with a join to be able to pull some other data in, and it's a really long running query. And let's say that update runs for 5 or 6 minutes. Well, while that's running, nobody else is able to, and it depends on the isolation level, which we'll talk about a little bit later, but when it's running, nobody is able to really access or do any other updates or inserts or deletes on that table. So what we usually want to look on that is how do we make that run faster? Again, it might come back to indexing at that point, or it might come back to something else. Another thing we see is that an update inside of a transaction that hasn't been committed yet. So you open a transaction, you do an update, and then you do something else that takes some time to do some processing. And then later you eventually commit the transaction. While you're waiting for that transaction to finally commit, there's blocking going on all those tables that you did updates with along the way. So one of the things we can do there is oftentimes queue up the work or maybe do all the heavy lifting ahead of time and then open the transaction and do a minimal amount of work inside of the transaction and then commit it. Another locking and blocking related thing that we run into a lot is updating more rows than you really need to. So for instance, let's say you're updating a row and setting a value that may already be set. So let's say you have, I don't know, a process date and then a flag that's a Boolean kind of flag that says is processed. And if you're doing an update that says update your table set is processed equal 1, where the process date is in the past, something like that. Well, it could be that that starts out with a small number of rows, but as that table grows over time, you end up doing that update thousands and thousands of rows or millions of rows. And what I like to do in that case instead is say, do the update set the is processed equal 1, in this example, where the process date, whatever the previous where clause was, and where the process date does not equal 1. And then what you're doing is you're saying, only update the rows where the process date is not already set. And that's one of those inefficient things you run into with SQL Server is that it will let you update a row or a column in a row to be exactly the same thing it was before. So really there's no change, but the amount of work that's required through the transaction log and being able to write the data page disk and all that, it's just the same as though you were actually changing it. So if there's a way to make it so your update statements are only really updating when something needs to change, that can make a big difference. There's a client we worked with where they had a website, and on every single web page view, there was something they were doing with an update like that. I forget what it was tracking, but we were able to just put in the where clause to say where the value doesn't equal what we're trying to set it to. And it eliminated almost all of their blocking by doing that update on that one where clause. So there's a lot of things that we run into with locking and blocking, but usually it's somebody that's making a change or doing an update that's either causing it to do more work than it should, or that's taking longer than it should, and we have to figure out how can we make those things faster.